One-to-one functions. For a relation or mapping to be a one-to-one function, it has firstly to be a function. Each input value for a function may only give one output value. So what we can't have is, say, an input value, an x value of 4, giving rise to both 2 and -2. This is easy to check if we can produce a sketch of the function as we apply the vertical line test. To qualify as a function, any vertical line must cut the graph at most once. It is okay for the vertical line to cut the graph once or not at all, but if any vertical line cuts twice, then it is not a function. So that would be the case here, where the vertical line at 4 would go through both 2 and -2. So that would be not a function. If we consider this one here, we drag this vertical line across. At any position, it's only going to cut the graph once. The same is true if we put a vertical line on here, but with this one, it's not cutting at all where I've drawn it, but when it gets to here, it cuts twice. So this one is not a function. Try sweeping your ruler across the 3 graphs above, as I indicated with my line. You should conclude that the first 2 are functions and the third is not. Once we have established a function, we need to decide whether it is one-to-one or what's known as many-to-one. To do this, we can apply the horizontal line test. If any horizontal line cuts the graph more than once, the function is many-to-one. So for a one-to-one function, any horizontal line will cut the graph at most once. So now consider a horizontal line like so, and let's move that up the graph. It's okay where it is, but when you get to here, it's cutting the graph 3 times. So that one is many-to-one. This one is okay where I've drawn it, but when I get to here, it's cutting twice. So it's many-to-one. Whereas on this graph, if we sweep this up, it only ever cuts once. So this one is one-to-one. So try sweeping your ruler upwards on the 3 graphs above, as I indicated. You should find that the first 2 are many-to-one and the right-hand graph is one-to-one. If it is not possible or convenient to graph the function, then you can use the following condition to prove if it is one-to-one. A one-to-one function satisfies the condition: if x is not equal to y, then f of x is not equal to f of y. So in other words, you can't have 2 different values of x, such as 2 and -2, giving rise to the same value. So if you think about the x squared function, both of those would give rise to the value 4. So x squared is not one-to-one, and you shouldn't be surprised because of the shape of the graph. We could also use the contrapositive. If f of x is equal to f of y, then that means that it's the same x value, x is equal to y. All you would need is one counterexample to show it's not one-to-one. So it only has to fail the horizontal line test at one point to not be one-to-one.